Hopefully by the end of this video, you'll have a good idea of how you find horizontal asymptotes using limits. What I've done here is I've listed out the steps for finding horizontal asymptotes. So step one is you want to determine the highest exponent of x. So it's kind of worded a little awkwardly, but you'll see what I mean in a second. Basically, x squared, x cubed, x to the fourth. You want to find the highest exponent value there. Step two, divide all terms by x to that power. Again, that'll make more sense when I show you in a second. In step three, evaluate the limits as x approaches infinity and as x approaches negative infinity to determine your horizontal asymptote. So let's go ahead and start with a function. And let's go with the function f of x equals, let's do x squared plus 3x minus 7 over 2x squared minus 8x plus 4. Okay, so let's look at our steps. Step one is determine the highest exponent of x. Well, in this case, I can see the highest exponent of x anywhere is squared. I do not have x cubed, I do not have x to the fourth, I do not have x to any higher order term, I only have x squared. So I've determined that. So step one, I'm just going to write this here as x squared. Step two is I want to divide all the terms by x to that power. What that means is both on the top and the bottom, I'm going to rewrite this, and I'm going to divide every single term by x squared. So this is going to be x squared over x squared plus 3x over x squared minus 7 over x squared. All over, I have to do it all again down here, 2x squared over x squared minus 8x over x squared plus 4 over x squared. Okay, so what am I going to do next? Well, I'm going to simplify these using the rules of exponents that I know and I hope you remember. One important rule of exponents is that when you're dividing any two things that have the same base and they both have exponents, all you're going to do is subtract the exponents. So x squared divided by x squared, if I subtract the 2's from each other, I get x to the 0 power. If you remember back, anything to the 0 power is just 1. Another way to come up with this is just recognize that x squared and x squared are the same value, and when dividing them, anything that's the same value, you get 1. For the next part, I recognize that this is 3x to the first over x squared. So if I were to subtract, I would get, let me do this over here, 3x over 1 over x squared. If I subtract these exponents, I would get 3 times x to the negative 1. Anytime you have a negative exponent, it goes down into the denominator. So this ends up being 3 over x. If you're a little hazy with this, don't worry too much because we're going to get a lot of practice as we go through the rest of these, but you should have this down by the time you have your test. For this next term, nothing reduces, so it's just 7 over x squared. Divided by 2x squared over x squared. Well, again, the x squared can just kind of cancel each other out. We're just left with 2 minus 8x, so I'm going to go ahead and do this one out as well. So if we have 8x over x squared, remember that's 8x to the first, so 1 minus 2 would give me 8x to the negative 1, and that x to the negative 1 does come down into the denominator, so we're left with 8 over x. And again, nothing to reduce here, so we're left with 4 over x squared. Alright. So now we've divided all the terms by x to that power and we've simplified. Now we need to evaluate the limits as x approaches infinity and as x approaches negative infinity. So let's go ahead and set that up. So the limit as x approaches infinity of 1 plus 3 over x minus 7 over x squared over 2 minus x, 8 over x plus 4 over x squared. So I'm going to show you how each of these terms disappears. I'm only going to do this once because then I'm going to tell you a shortcut, kind of a way to simplify the math that you do. So what happens to 1 as x approaches infinity? The number 1 is not a function of x, so it's just going to stay as 1. So 1 stays as 1. Now what about 3 over x? What happens there? Well, 3 over x, what happens as x gets larger and larger? Well, let's just quickly evaluate some fractions where the denominator increases. 3 over 1 would be 3. 3 over 10 would be 0.3. 3 over 100 would be 0.03. 3 over don't know, a bunch of zeros would be point, yada, 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 3. What we can see is our number is getting smaller and smaller the closer and closer we get to infinity. In fact, we could say that that number is approaching 0. As the denominator gets larger and larger, you're dividing by a bigger and bigger number, that 3 becomes more and more insignificant. So this whole term actually just approaches 0 as x approaches infinity. So that's going to approach 0. I can say something very similar for this part right here, this 7 over x squared. It's going to approach 0. In fact, it's going to approach 0 even faster than the 3 over x, because if I were to square all the numbers in the denominator, you're going to get to 0 really fast. Oops. So that's going to approach 0. 2 down here is independent of x. It does not depend on x, so it's just going to stay as 2. The x in the denominator down here, well, as that approaches infinity, 8 over that is going to approach 0 as well. And this one's also going to approach 0. So in the end, we're just left with 1/2. As x approaches infinity, our value is going to get closer and closer to 1/2. What we'll find with negative infinity is actually the exact same thing, but that's something that I'm going to leave you to do. I want you to try it. And basically see that you just get 1/2 as well. Negative infinity is, again, a very large number, so 3 divided by negative infinity is essentially 0.